There are 3 lines. So there are 3 constraints. So this is constraint 1. Because these are going up to, we don't know where they are going, because up to 12. X is 12. I'm just assuming that because at least I had problems with the scale. Yeah, I had problems here with the scale. But if the scale was okay down here, that would have been fine. You could have formed that one. So the issue is scale drawing, scale. The moment you have a good scale, you will easily identify that 2 is there, and then 12 is somewhere. When you connect that one, it means that one is your 3rd constraint. First constraint is this one. Second, it is this one. Third will be that one. But the only thing that we are interested is the feasible region. All right? Where we are interested is the feasible what? Feasible region. For example, this one. Let's look at this one. This one. Line 1, it is this one. Line 2, it is this one. Yabanga kati pa 3 and pa 6. So yabanga kati pa 3 and pa 6 paja. Then the other one is this one. Yabanga kati kuchokera pa jani? Yabanga kati kuchokera pa 2 hapo ukafika pa 12. So it is from 2 up to 12 hilo. Mkuona it? Now, which one is our feasible region? If you look at a feasible region, it's a region, it means malines on sewa they are sharing that part. Malines on sewa agwirabe ba part imene. That's what's called a feasible region. For example, if you look at this one, line yoyambirira yagwirabe pa feasible region. This one yagwira kuchokera line yikubwera osakala muntunda koma kuti tikufuna ku feasible region yagwira from there to there ndiye kuti it part E. If you go to line yomalizirai ndiye kuti yabwera E. Tibwere E yabwera pa ndiye kuti akafika uku yakafika ndiye kuti it is from, if you look at this one, it is from the first line is this one E. Line yamba ndiye yagwira apa kufika apa ndiye kuti yagwira malo awira. In other words, yagwira apa yapanga kati ma line onsewa kuma yakagwira ndi apa ndi this one region E. If you go to this line, you discover that this line yagwira this point and this point. You make it to be common. Therefore, this point is there. If you look at the third line, it has come all the way from here up to this one. It means yagwira apa the up. These are the points that we are interested. The points is 1, 2, 3, and 4. My points are interested in E, this, and this. All right, these are the points where you can either minimize or maximize profit. Profit and kuibanga kabina kuluza is based on these 4 points. So, it's where now we are going. I wanted just to identify my constraints can be, we are looking at it because we are looking at this, the third one, this one, negativity. It is because we are in this quadrant, because we are dealing with this quadrant. We can't go to another quadrant. We can't go to another quadrant. We are only in the positive quadrant. That's why X or Y should be greater than what? 0. We are interested in that quadrant.
Meaning that there will never be...
we can't go that other. I. Or positive. It's always be positive. We can't go to what? Negative side.
So we don't calculate this one, but we just know that
we don't calculate this one. We just know that condition deal with this one. But you have to include it because it is giving you a key that what we are dealing with, we are dealing with this.
Greater than
0. Where we have to be making is these ones. These ones. Comma E should be greater than 0. But these ones are less than us. Inequality are greater. Or it should be less or equal to. Paribe inequality means greater than here. All right? Unless maybe T1, it will be a condition. We'll look at another condition where it has to be greater than. We'll look at that one, maybe. We'll look at it within that one. But looking at this one, we are giving it to be like that. Let's go to another area now. Now, the issue is, how we at? All right, let's conclude now. Let's conclude. Now, if we are to conclude, if we are to conclude, we are only looking at less than here. We are only looking at less than, right? Does it mean that, oh, these constraints should have less than? No. Sometimes these constraints, they can take what is called a greater than. They can take a greater than scenario. And then I think we'll come up with that where we have got it, that it should be greater than. So in where you have got, can I just finish me with the greater than maybe? Greater than. Where you have got, if you look at what we are doing here, let me say it this way. All this because we are looking at less than, right? It means that the region we are interested in, it is this region here. It is this region. Greater than they will to region here to kupanga we interested with another region which is up. See, so ya musiya ya less than. All right, we get less than it because we are looking at this one. But if like here it were looking at greater or equal to 18, all right, they would have to come. Ndio kuti nika kuti tikayangane ya kuntunda imene pa greater or equal to what 18. They would I think our region will be playing around in the region imene ili mutunda. Sikhala so region imene ili musi. Here we are only looking at this region because everything is less or equal to. There is a problem here. One is this one. I think I will not, because of time, because what we wanted to say is for example, my solutions. How do we minimize and how do we maximize? All right? I'll just give you one example. If you look at this one, it has got negative, it has got less than, and has got what? Greater than, and has got less than. And here, and this one is negativity. Right? This one is negativity, right? But this one has got less than, greater than, less than. It means sitiyangana kumusuku ye ineka kuti tikwe will be interested in the mwamba. Right? Yeah. You plot all these lines. It was all less than. We were supposed to be interested in the yapasi, in the bottom. But because we are looking at one, it has to be greater than. Then what we are interested is, we are interested with one which has got what? This one. Isn't it? Then our next lesson we are trying to solve is we want to solve what are the solutions. How do we solve what is called optimal solutions? In other words, we'll be looking at what we are going to look at is we'll be looking at when you are solving these constraints, there will be one color which any modes. There will be one area, there will be one equation. Like for example, this one. All right. What you do is you are going to mark what will be x here. X is 0. X is 0. Y is what? 2. All right. What will be here? X is marked. Y is marked. All right. What will be here? X is 5. Y is 0. And then you look at all these points. So you'll be concentrating these points. Then you'll be told that for you to minimize or maximize, you'll be given a certain condition. That assuming it is 3x plus 4y. All right? 3x plus 4y, wanted to minimize. Then you take what is your x, what will be your y. Oh, from this one, x is 0. So it's be 3 times 0. Y is 2. 4 times is 8. So here is 3 times 0, 0. All right? Plus 4 times what? 2. So here is going to be what? 8. Then you go to another one. Okay. X is 5. 3 times 5, 15. 15. Y is 0. So here is going to be 15. So we'll be looking at these points. Where do you minimize profit? Where are you going to maximize profit? Where you are minimizing a profit, when you are minimizing a profit, it means that the value is small. Where you are maximizing, the way the maximum, it is big, right? So when you calculate it, you are going to get something which is very what? Very big. Therefore, those are what are called the optimal solution. So our next lesson we are going to look is what is called the optimal what? Optimal solution to linear programming. And when we look at these optimal solutions again, we'll go to what is called slug, and we'll go to what are called dual and slug. Is it called them? Yeah, conditions. We'll look at those which are called the dual and that. I have got soft copy. I can send it to you. I have soft copy for this one.
Don't forget.
Huh? Oh, I think. All right. Oh yeah, I will do that. Yeah. The next thing is tipange slack. Pamoja nipakosa pandu paliso slack variables and dual price, right? Can you check dual price and slack variables? Linear programming ilipo eti? Yeah, linear programming. I don't know whether I will teach you the duality principle. I don't know whether you learn about the duality principle in terms of the very same this. But yeah, feasible region.
Under mathematical programming, mathematical warfare, economics, Pareto, the fundamental theorems, application of integral calculus, analysis, general function models, application of linear economics, mathematics of risk analysis. Geo theorems.
Mnantumizira kosa utaleme.
Yeah, I sent it.
Can I?
Mathematical programming, step to H.
That's mathematical economics, eh? Okay. All right. Oh, so you said it is. We are looking at profit maximization, cost maximization, minimization.
Mathematical, we are on H.
Oh, programming, eh? Oh, feasible region and inequality constraints. So these are the inequality constraints, right? All right. I will just introduce you. Then we go to the geometry of optimization problems. All right. Yeah. We'll go to that one. This one, I think we'll go to that. Geotheorems. Okay. Then we'll go to linear graphics, linear programming, graphical solutions, simplex algorithms, interpreting of grade multipliers, graphical solution. Feasible region and inequality constraints. For linear programming and graphical solutions is the one that we will be looking at next week, because we will look at my solutions. What will be the solutions and how do we minimize and maximize? After that, we will go to the geometry of optimization problems in economics, and then we go to the cohort-ness theory. We'll look at that one, and then how to apply that. But I think okay. Assuming I can just go to another topic next week. Kuku attackers. All right. Yeah.
Optimizing and do application. Yeah, how we can.
It is
in real life.
All right. Okay. Fine. I think that is.
In real life, yeah, economics. This is what I'm trying to make.
Okay.
We are looking at us.
Okay. Thank you. Signing sheet. You can sign.